So welcome to the Veritas Automata Intelligent Data Workshops webinar. I'm going to challenge everyone to say that 5 times fast after this, and I won't admit how many times I practiced to get that right the first time. So I'm Ben Savage, the CEO and founder of Veritas Automata. If you were hoping for the actor, I'm sorry, and at some point I'll get tired of that joke, but it's been a long time. I am a recovering consultant. I've spent time in a number of different industries, from shipping to working with rocket production companies to most recently doing a whole bunch of work in an innovation team for a company doing inventory control and management systems. And now we have Veritas Automata, which is my own company. My team, I've gotten really good at solving problems because if you've ever been in a demo with me, it is likely to break or go wrong, or technology just tends to, which means I have to learn how to fix it. My team by default has also gotten really, really good at that because they can't put a 10-foot limit in my, they've discovered my ability to break demos even travels through the internet. So what does Veritas Automata do? So we're that force multiplier that comes in when you don't have a good answer to your problem. We can bring a team that will help you from an architectural standpoint, a software development standpoint, just as a set of business consultants to help you really design what your business process and approach should be. We can help you with all of those. We tend to focus in areas around automation, digital chain of custody, and we do with a heavy dose of machine learning and generative AI now as we do that. And what ties all this together is machine learning is the typical way you build those automation solutions with custom software. And then the digital chain of custody is how we are making sure everything is auditable and provable to our customers when those solutions are working. They understand why the results happen and why they got what they received. So our team is global. We are primarily through North and South America. We have people around the world, though, and access to talent wherever we need to go find it. Our headquarters is in Miami, Florida, but we have centers of excellence in Cincinnati, Medellin, Bogota, and San Jose, Costa Rica as well. Our team is very diverse, both in their education and in their backgrounds, right? We're going to bring everything from project and program managers to traditional developers to, we'll affectionately recall a couple of our folks mad scientists. That may or may not be due to their hairstyles, or it may be to their capabilities. But we've got a bunch of creative problem solvers on the team. And what gets them really excited are those interesting problems that aren't the easy ones for people to solve. They don't really like the boring ones. It's those challenging ones that get the team excited. We typically work through a series of phases or MVPs. And the reason I like to call this out, you can call this agile or however you'd like to define this process. But a lot of times when we're brought in, there's not a clearly defined problem, or there are several things that we identify that could be risky to go solve as we work through it. And in order to de-risk the risk that we find, the best way to do that is to do a quick test. You'll hear us refer to that as an MVP or a spike or just a set of experiments, depending on the project and the nature of the space that we're working in. The whole goal of those is to take something that is unknown and break that down into a set of more clearly defined steps so we can say, okay, we have an answer to this problem, we have an answer to the next problem, we have a way to get to your final solution you'd like to achieve. Or we have a way for all of us to say, this isn't working, there isn't a valid solution to the problem we're trying to solve. So let's take a step back and reassess our approach. So our intelligent data practice is what we've created to work around the generative AI and machine learning space and around the conventional analytics and reporting. And the reason we're tying those two together is a lot of times what people are doing with conventional Power BI and Superset and other analytics platforms, you can build some very cool tools to automate, and they may need some custom either machine learning or generative AI to help with that. Or the generative AI and machine learning tools may stand on their own. So this is a specific team that we've brought up and practice that we've brought up within our organization that are all experts in this space, and we can bring them to bear to solve our customers' problems. Part of what we've created is what we'll talk about at the end of this webinar, which is the specific bootcamp solution offering that we've created to come in and help somebody quickly assess their problem and develop a roadmap so they can say, here's 1 or 2 problems we can really bring this new technology in to solve and make us a more efficient business. I'm going to do some level setting here as I've kind of talked about the overview, but we're going to dive a little bit deeper into what is machine learning versus generative AI. I think this is really, really important. I'm seeing a lot of people as I talk with them out in the world be a little confused on this, or they're conflating the two, and they're not understanding what the differences are. So we'll start with that, and then we'll continue on talking about generative AI. So machine learning is a set of technologies that have been around for a long time. Some of them are going to be very similar to what you see in generative AI. The primary difference is these are deterministic, meaning that I can take the same piece of data, I can take the same algorithm, I can always get the same results. This is really, really important for a lot of use cases, like if you're using them in healthcare or if you're using them in finance. The other thing is that most of these algorithms used for conventional machine learning are also very provable. You can walk through each step of the algorithm and know exactly when and why it makes a decision, so you understand the results that you get out. That's important, right? When I'm looking at some of the traditional applications of machine learning that we've all encountered, fraud alerts from our credit card, right? Where we've gotten something that comes back and says, hey, there was an unusual charge here, or today I'm in Cincinnati, and all of a sudden 5 minutes later it picks up a credit card transaction in London. More likely than not, my credit card is going to flag that, ask me, is this a valid charge? It might be if I'm working with an online merchant, it might not be. By the way, when you're saying that transaction is good or not, you're also helping train their algorithm when you think about a supervised learning type solution. In healthcare, right? If we're using these to identify healthcare risks for a particular patient, we may see on their imagery that we're getting back that there's a potential for cancer cells. We can flag that to have somebody go do deeper review of that, so a human in the loop can make sure the AI is right or the machine learning tool is right. But it can be very well validated, and it's very provable before it even gets to the person on why it's doing that. We think about autonomous cars. I mean, we hope that autonomous cars are going to be very predictable and deterministic. And in some ways, they will fix some of the non-predictable human aspect of driving. If you've ever driven in Miami, you'll know what I'm talking about. But that's important, right? You've got to know, why did the car accelerate? Why did it brake? Why did it turn at this point? Or why did it swerve? Or why did it make this decision? If you can't prove that, it's kind of scary. And then image recognition is kind of a throughput, or is consistent throughout all of those that we've just talked about. So when we get to what is generative AI, this really blew up over the last couple of years with the ChatGPT, starting with ChatGPT 3 and the rest. By the way, GPT stands for Generative Pre-trained Transformer, which is the particular technology that most large language models, or LLMs, are based out of. When we come to image generation, there are a couple of other solutions that are part of it that are related to some of the generative pre-trained transformers, but they're also older technology, like generative adversarial networks. The generative adversarial networks are a little more better understood in some scenarios, in that what you're doing is you're having one set of models develop data against another set of models, and they're looking at it saying, did I fool the detection algorithm or not? Very, very cool stuff people have done with that. And then music creation can end up being a little bit of a mix of both of them. These are all very, very powerful tools. The key thing to remember with these is that they're not deterministic. And when I use the term deterministic, I'm being very deliberate. You cannot guarantee you will get the same results out of these solutions, no matter how much prompt engineering or guardrails you put around it. You can get more consistent results, but you can't guarantee absolutely you're going to get the same. Which is why it's important to understand when you're using, let's say, conventional machine learning versus Gen AI. What generative AI is really shaping up in a lot of scenarios to be is a tool that provides a very powerful interface to other tools. If you think about the way you can ask a question, we all remember, some of us remember Google, where you couldn't type even a remotely natural language. You had to remember how to use Boolean search terms, and that was how you went to find something when you were trying to do an internet search. You had to speak internet to do it. Now with these large language models, you have the ability to very quickly translate that human natural language into something that is more computer focused and get much better results than you might have otherwise. So they're very, very powerful. So I don't want to say that they're not good tools. They just have to be applied in the right place. As you're thinking about using a large language model in generative AI, you have to go through a series of decision steps. The first is, do I want to use a public tool, or do I want to use an open source and host it locally? Or do I want to go down a third path, which I'll cover on the next slide, which is I'm using hosted instances in one of the hosted environments. If I'm just using, let's say, ChatGPT, and I'm dropping questions into and answers into that, or heaven forbid, uploading corporate documents into that in a non-paid environment, you have to look at the terms and conditions. A lot of times what they're doing is they say you may own the data that you're submitting, but they may own the response back and have the ability to use that to retrain the model. What that means is there's a lot of information you may be unintentionally giving away that could be at risk to you personally or a risk to your business that you have to think about. If you're using an open source model, you have more ability to control it because you can usually run that on your local computer or local environment you can control. There's some additional headaches to go get that up and running. It's not as easy as just going and logging into chatgpt.com and making that work. So there's some trade-offs there you have to start considering. The other thing is how frequent the models are updated. We've all heard about ChatGPT where people say it's getting dumber. It's not really getting dumber. What they've done is they've either updated the model or changed the way it responds. So it's answering the question and responding in different ways. And you have to think of different ways to engineer that prompt again. With an open source model, you can control exactly when it gets updated and how it gets updated. But that means it may not always have access to the most current data within the model itself. The alternative to this is to use a hosted solution, such as what Microsoft provides through their Azure OpenAI APIs, or the other models that they host, or the Amazon Bedrock and the models that Amazon hosts. Both of these give you kind of a middle ground. If you're not ready to go stand up your own solution, but you need more control and more privacy than you may get through a public solution, this allows you to have a specific set of license for the model that you're going to use. Depending on your terms and conditions, you can control exactly when it gets updated, make sure it's only used by you, that no one else has access to your data and is not trained by that. So you get a lot of power from that as you're making the corporate decision there. So these are very, very good solutions. We're very familiar with working with both of these toolpaths, as well as doing custom bare metal solutions for customers if that's what they require based on their security requirements. So the main thing we've been working on is not, I won't call it a product. What I'll call it is a toolkit to help our customers very rapidly use any of these ecosystems they'd like to work in. So this is, we're calling this the RAG toolkit. It stands for Retrieval Augmented Generation Toolkit. Retrieval Augmented Generation is one of the primary techniques you can use when you want to use a large language model and maybe you don't want all your corporate data. It's not the right thing for your corporate data to be embedded in the model. And you want to guarantee that when your users are getting data back, they're getting accurate responses. It also makes it easier for us when using a RAG type solution to ensure the right people can see the right data. This all starts with what we would call document ingest, where we're taking that document, we are then starting to analyze it. And there are some tricks one has to do here, right? It's not just say, hey, go read a bunch of Word, PowerPoint, Excel, and PDFs. You're going to have to look at those documents and take the time to understand as your ingest tool brings them in. And when I say look at it, it's your ingest tool that's actually doing the work here. And okay, do we have to go take this PDF and do object character recognition on it because it's it's just a scan of a document. It's not actually a flowable PDF. Or are there deep and complex tables in this that we have to go do recognition on so that it's going to work when someone queries that specific table? Or are there tables and charts that we're going to have to be able to annotate so that a user, when they ask questions, get the right table and chart back? Those are all things that you have to handle at the time of ingest, so that way by the time it gets into the system, it's easy for someone to go actually consume that data. It's also here where we're starting to do our initial security checks when we're building solutions that require access control to make sure that user A can't see user B's documents, right? Because if you think about, let's say we're ingesting all of HR's data into the system. We better make sure that the right people can see that, right? Or if we're ingesting a company's entire finance solution system into it, we need to make sure that only the right people can see the right data there. It's super, super critical for making sure customers don't create any new vulnerabilities or access points in their system for people to abuse. So once we've ingested that data, that all goes into our vector data store. And at that point now, a user can start to go interface with it. And so we'll show a couple of different ways. That could be via the web, could be directly via Teams agent or a Slack agent, depending on which chat you use or whatever your preferred chat tool. There's a bunch of different ways we can create for people to interact with this data. And it starts with simply being able to query the data, bring searches out, do some simple analysis like summarization. As you have your data in there and we've understood what your use case is, then we have the ability to start building additional solutions on top, such as content and document generation based off your data. So I'm going to go away from this slide and I'm going to go into some quick demos now. So the first demo is one where we are using Teams plus the Azure OpenAI APIs. And here I'm just going to do a simple query to get a response back from the data set. In this case, we've got 6,000 documents we've ingested into the data set from the FDA clinical trials database. because that's a good one just for us to be able to ask it questions and get some data to see how we can make this thing perform. So here what we're going to see is I'm going to type in the question, and I'm going to ask it to give me a set of data on studies on a particular drug that we're using here. So there we have the response back. And so this is all the studies it found that were in our particular database result around this particular drug that we came in. So here I can go click on one of those and it will take a direct link. So this could be a link to an internal data source. It could be a link to a SharePoint. It could be a link to a OneDrive within your data set. It's all depending on where you store data. But the key thing is here is giving you access to a specific document so you can go see where it got the answer from. So the next one, I'm going to ask it a question on a piece of data that I know is not in the system. And you're going to see it doesn't give me an answer. This is part of one of the ways you can use the system and reduce and minimize and prevent hallucinations. So here we can see I asked it a question. There wasn't actually a valid answer to it. So it didn't try and give me anything. This one is a little different here. I'm going to go through and do a couple of questions here, one to get some data, and then the next I'm going to start to do some summarization. So here I'm asking a fairly broad set of studies on a particular type of lung cancer. So the next one, what I'm going to do is actually ask it to retrieve a set of studies and ask it to do some summarization. And one of the things we've learned is you've got to think about how to make sure these models respond appropriately. So it's not just that it gives it a response, but is it an appropriate response for the use case? In this case, you'll find in some of our other demos, we love making music and being very creative with these solutions. But if I'm asking it to give me a study on a cancer or a summary of a cancer study, it probably should not be able to get that as a song. Here, what you'll see is it ignores the song prompt and just gives the summary in the same way. And we've built the solution so that's very intentional in how it works. And that's something we can bring as we work with our customers to ensure that their data is going to respond the right way that's appropriate for their business. Here we're going to show some access control, and this is with a different data set. So this is with some financial records that we have. And what you're going to see, these are actually annual reports that we pulled from Edgar. And what you're going to see here is we've got two different users. User A is on the left, user B is on the right. User A has access to the Microsoft, and user B has access to Apple, but they can't see each other's documents. So imagine if we were pulling this from, say, corporate OneDrive or a SharePoint document repository that certain users had different permissions. We can inherit those. And so that way ensure that when someone is acting with the Teams agent that works with the large language model, they only get appropriate responses. And this is something we can help our customers with, not just from a Microsoft standpoint, which is the demo we're showing here, but if you want either just a purely web-based or you want one with Teams, we can help you, or with Slack, we can help you build those solutions as well. They do require a little bit more work in those environments where you're not leveraging the Microsoft permissions models that we're inheriting from Azure, but it's a very executable problem that we can help someone solve. So this is a little bit different one. This one is one where we've ingested the financial data, but we've also got some very specific table reading technology that we've built in. So you can ask some very intricate questions of that data to say not just the easy question, but the hard question when you're looking at a table 3 levels in to that financial document. So there you can see it's in the middle of a very complex table. And then when I go ask it for the 22 data, it's going to be able to do the same thing and pull up the same results at that same level of depth. That would be challenging if we were just to drop this even into a standard large language model. So you're going to ask now, what does this mean for me? That we've shown you all these really cool demos, and then you've made it clear they're not a product. Well, what they are a solution we can help use a customer to build a custom solution for their ecosystem or for their business. And it starts with our GenAI workshop. So the first day is one of our data scientists comes on site, and it may be more than one, depending on our team's availability. And they'll help provide some education for your team. And after they've gone through a deeper dive than what I've done in this webinar, explaining the difference between machine learning and Gen AI, and showing some examples of those, they'll start to walk people through some of the different Gen AI solutions that are out there and how people are applying large language models and image generation to their business, and walk through a couple of demos to show what might be possible. And then they're going to sit down and do both a little bit of discovery and a little bit of brainstorming. The first thing they're going to do is sit with the team and brainstorm and say, okay, what are the different things that might create tremendous value for you as a customer, if we could solve them using Gen AI and automation. Then the next thing they're going to do as they talk through that is they're going to be asking questions about what data do you have and what data exists. So at the end of the first day, we'll have conducted that. We'll have those initial ideas that could be valuable for the business with some prioritization around those. And then the team will go offsite and do some more work with your team, where what they'll be doing is really doing a deep dive into the data that you have to make sure it's of sufficient quality to potentially support those, and building out a roadmap to say, okay, if we solve these problems, what would it look like? We think it's going to take 1 week. We think it's going to take 1 year, and here's what all the different steps would be to go build and implement this solution for you. And then the last piece would be a follow-up, roughly 2 weeks after the first 2 days, where we'll present all of that data and say, okay, here were the results. Here are some detailed roadmaps that we think either our team can go do, or ideally it's our team. If not, you have something that you can use with one of your own internal teams to go build this solution. If you do it with one of our teams, we'll credit back a portion of the boot camp against the final project when we do it. And this is what we'd love to have a conversation about, is how can we help? Let's schedule one of these workshops and say, how can we learn more about your business and help you create some kind of solution as a force multiplier that you couldn't create on your own, and we can help you move faster. So I'd like to thank you for joining the Veritas Automata Intelligent Data Workshops webinar. We'd love to have a follow-up conversation with you. You can reach out to us via LinkedIn, or you can connect to me directly, or you can connect to any of my team, and we'd love to have a conversation about how we can help you solve your problems.